All right, folks, thanks for showing up. You're in the breaking ground track. If you are not looking for the breaking ground track, maybe you could go look someplace else. Or stay, because I think we got something interesting here. One last thing for anybody who hasn't heard, the blue cell phone was left in a cab this morning. It's turned into hotel security. If you're missing your blue cell phone, talk to hotel security. Or if you just would like a blue cell phone, maybe go talk to hotel security. I'd like, but I'm sure that would never happen. I'd like to welcome Ryan J. Chapman and Moses Schwartz from the Bechtel Corporation. They're here to talk to us about their framework for automating stuff. Put your hands together, please. Thank you.
You set the bar high. You already clapped, so we can't suck now. All right. So I'm Ryan. This is Moses. I'll learn not to smack my mic as we talk. So, just to get into it here, the agenda for today, we're going to talk about who we are, where we're from, what we do, our goals and intent for the talk. We're going to discuss the concept of an Intel shop and try to get everyone to move toward being an Intel shop if you're not one already. Then we're going to go over the process, at least that we use, to analyze indicators of compromise. And then we're going to talk about our tool, Cassava, and get into that. It's our official tool release day. Yay! And then we have a discussion, wrap up, and questions and such. Okay, so my name is Ryan Chapman. I work incident response with Bechtel Corporation. I have some degrees and some certifications that really no one but me cares about, but the important things are I'm a retro gamer, so I have quite a few old retro consoles. Like if you're into 8-bit, 16-bit, like yeah, dude, let's do all that, right? My wife hates my collection. It's too much stuff. I'm a husband and a father. I've got a 4-year-old daughter who runs around and touches all my things and does whatever she wants, and my wife does the same thing. So
I'm Moses Schwartz. Can everyone hear me? We're good. I work with Ryan at Bechtel. We're both on the incident response team. I've got a degree. I've got no other acronyms. I recently moved over to industry. I was with government and national labs before. Did a lot of work in industrial control systems. And I think that's the end of my slide.
All right, cool. Next up. So what is a Bechtel? Anyone here heard of Bechtel? Except for the people I work with back there, you don't count. Okay, so Bechtel's one of the largest construction companies in the United States. The numbers flip-flop, right? One of the largest in the world, engineering and construction, excuse me. We build mega projects. When I say mega projects, I'm referring to projects in the tens of billions, potential of dollar value, like mega targets. And because of that, and because of the things that Bechtel builds, we end up being a high-value target. So we deal in the nuclear sector. We deal with, in fact, we'll show you some of our projects going up. I won't go into a whole rant on that, but the idea is very simple. When you're dealing with government contracts and dealing with things where you have these like nuclear facilities with your name under them, under your umbrella, you become a target. Okay, which is actually kind of cool. No, I didn't say that. But it's actually kind of cool for us because you get to deal with maybe adversaries that other companies don't get to. So, all right. So some about Bechtel. We built the Hoover Dam. I'm sure you're all familiar with that, right? Local. Palo Verde Nuclear Generating Station. And this is actually really cool. This is the Pueblo Chemical Agent Deconstruction Pilot Plant, or we call PCAP. So we have all these chemical agents built up for different wars in the past, right? And because of certain treaties, they have to be dismembered. We have to get rid of them, right? So we take care of those types of things. And then we have Ivanpah, which is these huge collectors built from mirrors, and we harness the power of the sun. Yeah, renewable energy, right? So just a little smidgen of some of the things and projects that we deal with. Okay, speaking of our team is comprised of, well, quite a few number of smaller subsections or arms of our overall global security operations and engineering, but primarily I want to talk about these three teams. Okay, and one of the things that I really want to talk about here is what we do, but then I also want to get some feedback from the audience, so hopefully you're willing to do that for me. But we have a Security Operations Center, which is a 24/7 incident response team. Okay, this team is primarily responsible for incident response within our organization, which you may be a little confused because we have the team one down from that, which is the Computer Incident Response Team. And you're thinking, well, wait a minute, incident response is in that title, so what's going on there? So our team, the CERT, we do the engineering. So we stand the tools up and we maintain them so that the SOC can use them, right? That's what we do. We provide expertise in the sense of if we have a real, oops, situation, we jump in and do incident command for the incident and stuff like that. But our SOC handles pretty much 98% of any incidents. That tickets to come in from our SIM, from our log management utilities, I'll leave the name out, right, all those. So we also have a TMT, a threat management team. And what they do is they try to mitigate threats. And what I mean is they run the vulnerability scans, they perform patching, do service count, reset passwords, stuff like that. Our overall goal is to deter, detect, respond, and remediate. And one of the best ways to do that is through utilizing intelligence. I'm sure you're all hopefully on the bandwagon, the intelligence bandwagon, right? Otherwise you wouldn't be in this talk, jeez. Okay, so do you have these types of teams at your work? Anyone want to volunteer if you have this type of segregation? You do? Do you have the same three, or what do you have? Oh, you have a cloud team. Team just dedicated to cloud. That's a good thing. I kind of like that. All right. Anyone have an intelligence team, like just a team for intelligence vetting and analysis? Really? You do back there? A couple of them, huh? All right. We should talk later and see how that works out. All right, but how many of you, be truthful here, how many of you have like 5 guys who do all the above? That's it? Come on, more hands need to go. Don't lie. All right, yeah, that's. So we're lucky in this regard that we have these teams in this fashion. So if you want to talk after about team formation and how you guys are running through Intel and so on and so forth, we'd be definitely happy to do that. So, all right, our goals and intent. We'd like this to be an ongoing discussion. I'd like feedback from the audience. There's a mic right in the middle right there. I don't know if we have a floating wireless one. I don't think we do right now, but. If you want to just grab that, and if you want to just jump in or just yell something out, I'll repeat it for the camera. That's perfectly fine. Besides, they really want to engage the audience, and I do too. We do too. So let's do that. So the Intel shop, the idea of the Intel shop, producers, not mere consumers. We don't just want to consume intelligence, take it for face value, and say, oh, that's cool, block it in the firewall, and move on. We do not want to do that. Okay, how many of you do that? You're like, I do that. Right? All right. So what we want to do is we want to exploit the information. 2 primary ways. Number 1 is to derive additional intel from that so we can further analyze it. And the other one is to vet that intel. And honestly, I probably should have flip-flopped that. We want to vet it first and make sure it's even valid intelligence. Okay. So speaking of vetting intel, does anyone here, you don't have to say the names, right? Are you part of intelligence sharing groups? Like, right? Yeah, open source intelligence sharing groups, right? Can you throw any names out of those groups? Threat Exchange? Cool. Everyone's like, no, shh. No. Shut up, Brian. Keep going. Next slide. All right. So when I say pivoting, I want to discuss this. It paints a clearer picture of what we're dealing with. All right. So an example of data pivoting, if you're like, what are you even talking about? Say we're given a domain name. All right. That domain name is an atomic indicator, and a lot of people just use it as face value and say, this is a domain, block it in the firewall, move on. No. Check the passive who is. What's the registrant name? What name server does that use? And for that matter, if you check a name server associated with a malicious domain, and that name server hosts only 2 other domains, you probably want to look into those 2 domains, right? That's the concept here. So if you have an IP address, well, how many domains are hosted on that IP address? And what registrant information did they use? And so on and so forth. So that's kind of the goal we're going to get into in the discussion of data pivoting. And when you pivot, you're able to hunt throughout your network. All right. Anyone here use log aggregation utilities? Yeah? You want to throw your names out? No one wants to share names. Whatever. What's that? Elk. Awesome. Cool. Elasticsearch. Cool. Good deal. Okay. Before we start getting into how to pivot through intelligence, there's a very important discussion to be had here regarding operational security, or OPSEC. Okay, so I already see you're laughing already. You know where I'm going with this. Okay, there's 2 different types of threat intelligence gathering, and if you think of it, just think of it like standard recon, right? You have passive and you have active. So the basic difference is passive, the threat actor against whom you're accumulating this data or whatever, right? They have no idea you're doing it. You're checking passive DNS stuff. You're not actively making requests out to their infrastructure. Whereas active is the exact opposite, right? You're like, hi, I'm looking at your stuff, okay? And we have to be very, very careful on how we deal with this whole thing, because our operations team might not want us to be putting our names out there like, oh, we're looking through your stuff, yay. You have certain APT groups, and you're like doing all this recon on them, you might attract attention, right? They're like, oh, you have it, what are you doing? And then, of course, you also have sharing agreements. So like when I asked which sharing or Intel threads you're all using, and like no one's like, shut up, Ryan, right? In that case, that's the same thing. Maybe they don't want you to actively probe out and let people know that you have that information. All right, and overall, just tipping the hat is bad. All right, it can be very, very bad. The simple thing is, if you have a spear phishing campaign that comes into your organization and it has targeted just your organization, and all of a sudden you start pivoting off that data and that intel, they know you're doing that, right? And so I don't know if you want to do all that. So we can talk about that more after, and how you actually, what network do you come from, right? Does anyone here do that type of thing? You receive intelligence, you try to pivot back and learn more about them? All right, for those of you that are doing that, are you going through Tor? Are you going through your internal network to make it look like a regular user? What are you doing? What's that? Cell card. All right, that works. What's that? One more time. What was, sorry, the last one? Oh, yeah, okay, cool. Lines, maybe you have a non-business line, right, in your security operations center or something? Yeah. Anonymizer, right? Many different anonymizers out there. Cool. Hopefully you're going through different exit nodes almost every time or something, right? Yeah. Awesome. Kill the circuit, bring it back up. All right, so IOC analysis process. We're going to talk about some of these atomic indicators. Now, when I say atomic indicators, I mean just the primary indicator types: email, domains, IPs, and file hashes. Okay, so right now you may work with these in certain ways. We're going to discuss some of the ways we work with them. Hopefully you have ideas and we join forces and Voltron it up here. So email, we have an email that comes in, and quite often people just take like the from email address, they pop it in their, not the vendor we use, their email blocking utility, that I'll say. They put it in their whatever exchange, whatever's sitting in front of exchange, right? They block it, and then they just move on with their life, okay? But that email has associated with it email addresses from and reply to might be different. Why are they different? Well, look at that, right? SMTP servers they're coming from, like check the hello, like where did this really come from? Where it's purported to come from, or somewhere else. Xmailers, you guys all familiar with Xmailers? What's the other term for an Xmailer? Like in a web browser, what do you refer to that string? What's that? Yes, the user agent string is what the Xmailer is, right? So it's identifying the mail client. Like when you visit a website and knows you're coming from a phone because you provided it. Yeah, right. So the Xmailers, you can see if they're using a specific Xmailer, well then maybe they're using that for all of their malicious activity, which they commonly do. Subjects of the email, so on and so forth. Okay, so here's an example of an email that we kind of broke down. Technically, this is a screenshot from CRITS. Anyone familiar with MITRE's CRITS project? Yeah? Awesome. Okay, cool. So this screenshot is just, it's kind of a funny screenshot. This is Moses sending me an email. It's in reference to our DEF CON 23 submission, or our, I should say, rejection for DEF CON 23. So I'm just showing here that we have the reply to. It does happen to be Moses, so I mean, that's good, right? And then we have the hello over here, so we see it did come from a Google server. And then we've got, down at the bottom down here, hello, our iPhone Xmailer. So I know where it came from. All right, domains and IPs. So when a domain or an IP is provided to us through intelligence gathering, or for that matter, it's not all just shared intelligence. It could be a spear phishing campaign that comes in from which we derive the indicators, right? We extract them out. Okay, so I want to find out, is this domain reputable or is it not in general? Okay, so some of the things I would do is I would check who is results. Okay, we like to use some mini tools. I'm just going to name a couple on these slides. Domain tools, RobTex. What else are you using? Simon? I haven't used that. I'll check that out now. All right. Anybody else? Whoisology? Others. I'm going to go check these out now. All right. That's the point of this conversation. Whoisology was the other reference. You also want to check for reputation scores and blacklists. So is this domain a known bad domain? All right. So we can check Web of Trust, URL void, OpenDNS. All right. What are the tools you're using for reputation scores? Anyone? What's that? Emerging threats. Cool. Okay. And then malware site hits. So you want to see if they have hits on various malicious software sites. Of course, VirusTotal's on there, malcode, right? And the idea there is, has this domain been associated with any known bad samples? Okay. All right. So anyone have any feedback, any additional things that you're doing for domains or IPs in this? Yeah. Yes. Oh, yeah. Oh, yeah. To repeat that, what he based the feedback we got here was just a note on whenever you're using VirusTotal, whatever malware samples that come down to you, just do hash lookup stuff. Don't actually submit the sample. We have a very, very, very strict rule on getting that approval for that. Because if it's a targeted sample that's just written for your company, and your silly butt's like, wee, VirusTotal, then they're obviously sitting there watching it going, oh, you're analyzing it. Yes? Well, change what? Change a byte. Yeah, give them a different hash value, right? Yeah. Well, if you change one byte, though, you might run into some other problems, which we're going to talk about when we go over the file hashes, import hashing, but you're probably familiar with that. It seems like you are. Yes? Passive total, yes. I just signed up for an account. Crowdsource? Mm-hmm. Cool. The one reference was passive total, so if you haven't checked that out. And by the way, one of the important things of having these passive databases is it alleviates you making all these queries and reaching out. It's already passively obtained by this third party. Okay. Click. All right. For Whois results, we have some data pivot points. How are we doing on time? We're good. Yeah. Whois results, we have some data pivot points, dates for created, updated, and expired for domains. Okay? So if you see a domain that comes in that's quote-unquote malicious and being leveraged as C2, right, command and control infrastructure for like a known APT actor, and you look and the site was created like literally hours prior to you receiving the intel, you're like, oh, that's not good. But then again, if you have one that maybe was created 5 years ago and renewed ever since then, what does that probably tell you? Yeah, they've been hacked, right? Yeah, it's not necessarily saying, oh, that means it's a good domain. It means, well, it's currently not our good friend of ours. So we have name servers, the domains associated with, the registrant, I should say, contact information. And then, of course, you have like names, organizations, and addresses. Now, a lot of people, when I go over this part, they're like, why would you look at the registrant contact names? They're going to be fake, right? Well, yeah, oftentimes they are fake. But this is a human error type of thing. This is when the threat actors fail, essentially, right? And they do things like they reuse the same fake information. So if I'm looking at passive information, right, and I have this name like John Jacob HHK, some random name, right? But if that exact same name is associated with 4 of the domains that were all registered around the same time, I'm probably going to need to look into those. So it's still definitely valid. Okay, file hashes. We're going to get into file hashes now. So you have a file hash. You run whatever you prefer in your shop, MD5, SHA, whatever. You can get association to other related samples through signature-based association is one method. So this one, it's kind of with all the generic signatures that the antivirus vendors are using these days, it's very difficult to get a lot of utility out of this. So are you all familiar with some of the more generic signature or detections that various AV vendors are using? Anyone throw one out? Trojan dot? Gen, yes. Yeah, if you go just search that on VirusTotal, see what you get, man. Yeah, dude. No, it's a Trojan. Just toss it in there. Trojan.insight. McAfee's got their own. I can't remember the name right now. So when you see one of those generic names, like you're not really going to go look at every other sample that has that name, okay? But if it does come up as something a little more threat actor related, like Dooku or something, you're like, well, wait a minute, right? That's a family from a known attacker, well, known set of attackers typically, and it gives you an idea of where to look next. So we also have import hashing. Anyone here familiar with import hashing? Yeah? You want to explain it? Yep. Perfect. Perfect. Cool. For those of you that couldn't hear it, you're basically saying that the import address table within a portable executable, Windows executable in our case right now, it imports various Windows library, Windows API functions, right? Well, if the malware is just slightly modified, like maybe to attack one group to the next, you're probably importing the same functions. You know, you're importing your URL mon for internet-based calls and so on and so forth. So when you have that table built up, you can hash just the imports. So any of the text-based strings that are passed to those as arguments or whatever, if that's the only thing that changes, you still can actually find out that the sample's related. If some of you are looking at me funny, if you have a VirusTotal account with VirusTotal, like an actual account, you know, with them, an API key associated account, you go into the actual intelligence section, you click on your sample, and then you'll see by the hashes, right? So you're going to have your hashes, like underneath, I think it's the SSDeep section right underneath there around. It says import hash, and if you click on it, it'll run the hash correlation for you. Or just, obviously, we're using API calls to do the same thing. So that's actually a newer thing, pretty cool. Another thing that's awesome is this tool called Pivoteer by one of our coworkers, and he has gone through, it's available at the GitHub location here. And so what he has done, Rick, is he's gone through and he's utilized section-based hashing. So sections within the PE. So if you're familiar with the resource section, the code section, the text section, things of how the PE itself, once it's compiled down, those things can be hashed themselves. So, for example, say there's okay, this might work. Say there's a .NET application, right? It's compiled in C#, and it has a GUI, and it uses a very specific look to it, right? That's all going to be probably in the resource section, okay? But they changed the code in the what technically would be the text section, but the hash for that resource section will be the same. So yeah, that works. Yeah, I like that. I made that up on the spot. All right, I'll take that. I feel good about that. So check that out if you want to take a look into that. And then, of course, malware sites. So we want to run the hash against, and this goes right back to the don't upload the sample unless you've had a big discussion about doing so, right? But you want to look into VirusTotal, malcode. What other sites are you using for file hash lookup? Malware, right? Yeah, you spelled it out because you didn't want to pronounce it like I tried. Yeah. Malware, I don't know. All right, yes. So malware.com. What else? Total hash? Yep. What else? Can we use Bit9? What, two? Okay, two. Like, I use Bit9. I do. Awesome. And then we have known software association lists, right? So the National Software Reference Library, the NSRL, acronyms are difficult for me. And then Whitescope, which is something that Moses found. You want to explain Whitescope?
Yep. Oh, Billy Rios, I forget the name of his company, put this together. It's a hash set of known SCADA software that he's collected over the years. So you can look up hashes and see, not if something is bad, but if it's a known piece of ICS-related software that's in the database.
Which can be cute when you're scanning your like general use VLANs and you find all this SCADA software. And you're like, what's going on there, dude? Why are you doing that? All right. Okay, tools. So who here is pivoting off of intelligence at this point? Okay, what tools are you using to do it? When I say tools, we talked about resources thus far, right? So what tools are you using to do that? Python? All right. You're just writing your own script? You have a script that just kind of runs through, or, yeah? Okay, what else? It's difficult, right? You have all these different sources of intelligence. Some of them have APIs, some of them don't have APIs, and you kind of want to put it all together, but then you run into some problems, right? So what we're going to talk about right now is, Moses is going to talk about right now, is a tool that we're going to be releasing. And in fact, I'll turn it over to you, man.
Okay. Are we on the... So we've got this clever acronym, TAPIOCA, and I'll tell you what the tool's called on the next page. But this comes from a lot of the work that we put into doing this kind of analysis. We're a very script-driven group, like we were just talking. You know, everyone has their own Python scripts. You tie into APIs. You pull in other tools where you can. You try to automate this domain and IP vetting process. We've got a script we call Bacon that our SOC is actually using for their vetting. We've got Tapioca, the original version, which was like 40 different scripts that I wrote because we would periodically get these big dumps, 5,000 IP addresses. They might be bad. What do you do with that? You can't block them. So, I started writing these scripts that do API queries and pull in VirusTotal and OpenDNS and whatever other services you've got. Put it in a big spreadsheet. You can start to sort and maybe at least find a few that are interesting that you definitely want to block because they're on, already known bad lists. And it can give you an idea of where to keep looking to hunt and find other information. Scripture is a tool that I put together for our group that's open source on GitHub that was intended to make it easier to take these Python scripts that everyone has with their various dependencies and put it all into a single web server, give it a really minimal auto-generated web interface, and also expose those scripts via REST API.
Let me jump in there. I actually went faster in my part than I thought. I would talk all day. So let me ask you, how many of you, so what you just referenced right now was a modular platform where you take the scripts that you, and you create, and you pop them on one web-based interface, and everyone just accesses it, okay? How many of you have a problem because you don't have that type of setup? How many of you have your own scripts, and that guy has his scripts, and that girl has her scripts, and you try to, which version are you running? Did you do a clone? I don't know. Did you pull it recently? So you get into all these problems, right? Well, it's awesome. Whenever I write something, I just go, hey, Moses, can you do the thing? And it goes on to Scripture, and I'm like, yay, it's right there for everyone to use. So, yeah, it's really, really useful to check that out. Yeah.
Thank you, Ryan. So the tool is called Cassava, another name for Tapioca. It's the same root. It's a Python library, and it ties into Scripture for the web interface and REST API stuff. Basically, we're just trying to pull together a bunch of APIs. Right now we've got OpenDNS, VirusTotal, a couple system utilities, Whois and Dig wrapped, and we are wrapping the tool Automator, which goes and pulls from IP void, URL void, a whole bunch of other sites to look up domains and IPs. It puts all of them into kind of a consistent interface, massages the output so it's a little bit easier to work with. A lot of these APIs, you've got to know that you've got to look for the XYZ element in their JSON that they return to actually get to the data. This simplifies it, puts it all in one place, and it also stores this in a local database. So you've got a cached storage of all these lookups you've done. That'll let you see, have we done a lookup for this domain before? It also makes it a lot easier to do live analysis, because usually you don't want to have to save everything out when you're doing all these calls and then piece it back together when you want to do your analysis. It really cleans up your code if you can just leave it, the API calls as they are, but actually have the results returned from a cache. So you don't have to go out and reach out to VirusTotal every single time you want to look at the same file while you're doing development. This is up on GitHub at our cert repo. The name is Cassava.
Let me jump in real quick. Is
Yeah.
that cool? One good thing about having that cache is, for those of you who have a team of more than one person, if you have intelligence that comes in, or for that matter, just tickets, right, that one of your malware analysis runtime environments may fire off, whose name you probably know who I'm talking about. So they shoot a ticket into your SIM, and another ticket comes into your SIM. Analysis is going on here, and analysis is going on here, but all of a sudden, this person runs Cassava, and then this person runs Cassava and says, wait a minute, that was cached like 2 minutes ago? And well, who's doing that? And then you can find out right away that there's a correlation with these new incoming, quickly firing events. So that can be very helpful.
Now,
Cool.
I mean, we don't actually have that in the interface yet, but that's where it could be helpful.
Yeah.
Let's not oversell it.
Okay. All right. Touche.
So when putting this together, my goal was really our goal, sorry. It was to make IOC analysis easier, to make it simpler to pull these APIs together, and not just that, but to be able to easily get information from a multitude of sources. Because one may not be reliable. If you've got a lot of hits on a lot of sources, if something is suspicious, then it's probably worth looking into. I'm also really focused on this being a library that can be reused. One of my pet peeves in this whole security industry really is a lot of tools are written just as tools. And the only way to integrate it into another project is to actually go do a system call to execute it and read in the output. And that makes it a pain in the ass to actually build new applications that use those capabilities. So I did everything I could to make this modular, extensible, and through the Scripture framework, it's got that web interface and the REST API. So you can use the network, or do API calls over the network to build your other tools. You don't even have to import Cassava directly.
Wait.
Yeah.
Leave that on the screen. You see his rant down there? Right, was just talking about the monolithic programs. So one of the guys, former from our team, Chris Brewer's his name, designed the idea for the tool called Bacon. And I took it, ran with it, and I ended up writing this huge monolithic script, like freaking. So Moses is like, what about the talk in Tapioca? And I'm like, oh, just, decompile, not decompile, just take the composition, the parts you like, and just pop them in there. So he goes through the Bacon code for a couple days, and then all of a sudden he starts this rant about, I hate people. And he starts going off, it's so horrible, it's so hard to port. I'm like, all right.
No,
Okay.
It's not just you, Ryan. I mean,
All right.
has anyone ever tried to use Wireshark or T-Shark? You want to get at the dissectors, use them as a library. Like you'd like to pass it a packet and get something back, right? Has anyone ever done that successfully? I ran a T-Shark and had it export to XML and then read that in. That's the best way I could see to do it. And every single tool is written that way. So I'm not saying I'm changing it, but I'd like to mention that. Like, anytime possible, modules, libraries. It's really cool. So on to what this web interface actually looks like. We've got a couple examples here, and then there will be a demo, if we're lucky, at the end. So this is what the auto-generated script input looks like. We've got a number of GUI elements you can put in there. You can define checkboxes, radio buttons, multi-line input, and single-line input. Right now I've just got bsideslv.org. You hit totally, and it looks it up in VirusTotal, spits it out as JSON in the database, and then displays it on the web page in an HTML formatted table. You can also click the tabs for JSON, get directly at that. You can copy and paste it out of there. CSV, Python, and a few other formats. This is really just making it easier to integrate this into your workflow. I mean, a lot of the work we do is you put in a bunch of domains, and then you copy and paste the results into a ticket or into another tool. So the goal there is just to make this as painless as possible, provide all these utility functions that otherwise you'd have to open up Python and run yourself or write a small script to do it. It should all just be in one place. There's also the REST API that I mentioned. So if you can see the URL up above, we're at /API/version2, VirusTotal_domain, that's just the name of the script. And then apparently that input box is named domains, and you just give it a list of domains. And it returns JSON right there in the web browser. You can do this from curl. You can do this with other tools. You can also import it as a library. Right here I'm doing the exact same example, importing Cassava, doing this VirusTotal domain lookup, and then just pulling out a couple fields from there showing it's in there. We've got 0 positives, 63 total scans. There's the permalink to the VirusTotal report. So we've mentioned the database a few times. Right now, if you go into install Cassava, it's SQLite, which I love for development. For production, I think Postgres is going to be the way to go if you want to actually put this on a server that other people use. There's actually a really solid rationale for that. I'm using Python SQL Alchemy to interface with the database, which makes it pretty much database agnostic, but it means that you can't use most of the NoSQL solutions. Postgres is awesome because they actually have a JSON data type now. So when we start to build more analytics on this database, looking at our previous history, you'll be able to just query directly on elements within that JSON blob if it's in Postgres. I feel almost like we've said everything on this slide.
Yeah, pretty much.
Yeah. Okay. So once we've got this data, what do you do with it? We have already mentioned CRITS. It's an open source project out of MITRE to help with this IOC analysis. You enter in IP addresses, domains, emails. It parses a lot of things out. And it has a number of modules they call services that'll do actually the same kind of lookup we're doing. They'll look it up in VirusTotal. There's an OpenES module. I don't know what other services there are, but you can't easily get those services into other applications. Again, back to my rant. So we want to integrate a little better with CRITS, expose our library as a service to CRITS, but also have some functions to export directly into CRITS. So every time you run a query, it's cached in the database, but it could also automatically be sent to our CRITS instance and put in some kind of suspicious or looked at once bucket, and you can do analysis on that side. We didn't want to replicate work. It could be kind of fun to start talking about correlations and grouping domains or other IOCs, but really CRITS is a great tool. So we just wanted to integrate with that, kind of settle on what's becoming a standard. We're trying to make everything we do talk sticks and related XML formats. But there are some other things that we can do with that data. It doesn't all have to go into CRITS. And the CRITS services aren't necessarily going to get all the information we want. Some of the stuff we've done is taking these open API lookups, but then also looking into our own logs, pivoting from there. We've got a database of IPs and domains when they hit our network, like down to the second. So we we'll see an IP, we'll look it up and all this, but then we'll also go take that timestamp and go look in our SIM and see what kind of net flow data we can pull out, what protocol was that domain on, pull this all into a big table, and then we can analyze it. You can dump it into Excel, and you can try to sort by size of files transferred, or results from virus total, number of positives. I've also been playing a little bit with data science, as it were. I don't want to make any overly large claims here, but Python is awesome. The pandas library is a data frame manipulation library, basically. It gives you a MATLAB-like matrix and all sorts of transforms and operations you can run on it. scikit-learn is a collection of machine learning algorithms, so it makes it super easy to whip up a Bayesian classifier or something to try to come up with whether an IP or domain is suspicious based on what we've already seen on our network, like what we've already got in our blacklists. Now, I've got a big dump. This is anonymized of data here in a spreadsheet. There is a prediction column there, targeted, probably good, malware. Turns out the prediction was terrible, but but that's the way I want to go. And once you've got this kind of large data set and it's accessible, you can really start to do some very powerful analysis on that. So if anyone wants to get started and run this tool, it is super easy, or I hope it is. It's up on PyPI, so you can do pip install Cassava. I highly, highly recommend you set up a virtual environment before you do it because it has a lot of dependencies, and really I just recommend virtual environments for all Python development. Then run the run Cassava script with this init config argument. It'll dump out a minimal config file, and you can put in your API keys, and it'll read that back in and can actually start using it. Okay. It's demo time. We'll see how it goes. So I mentioned Scripture. I'm using it as a library in this Cassava tool. So the splash page says, "Welcome to Scripture." It might get a little bit confusing, but that's the way it is. This is the tool that we use to consolidate scripts and have them all run in the same place. So let's see. So I'm going to go ahead and go to the TAPIOCA tab and put in a bunch of domain names. This is pre-prepared. These are in the cache, so hopefully this is going to work. And summarize output, this narrows it down to only a few tables. Oh, it didn't fail.
Okay. That's a good thing. All right, cool.
So here's this HTML table. I apologize for the user interface. I know horizontal scrolling is bad, but it's a lot of data. We've got, let's see, a few fields pulled from virus total, the positives and the total. The status is open DNS, security rank as well. And then most of these others are tools that Automator is pulling out and we're using. You can grab that in JSON, CSV, then open that up in Excel. Python, you could paste this into a terminal if you like. And a couple of others that are probably less useful. Track is useful if you happen to be using Track for ticketing. Markdown is useful if you want to drop this into your GitHub or something. YAML, I haven't used in a really long time, but someone might. Let's see. And you can also access each of these parts of the API individually. So we can do the open DNS related domains call, put those same things in, and let's see, they think besideslv.org related domains are besideslv.org, bluecoat.com, blackhat.com, defcon.org. That's pretty reasonable. Apparently wired.com is related to Black Hat. We've also got these active lookups, whois, dig. Those are wrapping the system tools. That's probably only going to work on Unix systems. Automator, these are all the sites that Automator can access, and we access through it, like a library. Virus total. Right now, we've got part of the virus total API implemented, full OpenDS API from their open source investigate Python script. Like I said, Automator, Dig, Whois. We'd like to add a lot more. Domain tools is probably top of the list. Every other tool that we mentioned, I'd like to get it in here, be able to go to just one single place whenever you want to query an API. Because every time before I would try to write a script to do something, I'd go Google, what virus total API was I using before? And there are 14 of them on GitHub for Python only. And it's unclear which is the best, and they're all a little bit different. And half the time I just ended up writing my own REST query, using the request library, because that was easier than dealing with the API. Hopefully this makes life a little bit easier for everyone. I'd like to see this become something really useful.
Show the TAPIOCA results again. You got to show the TAPIOCA results again.
Oh. You want to do the full verbose output?
No. Now I'll click. Do the B-sides Las Vegas Fortinet classification.
Oh. I'm going to do summarize output. Okay. B-sides LV. What are you looking for?
Which one's B-sides?
Let's see. Bitdefender category, hacking, and no category for the other two.
Which one's B-sides? Which?
B-sides is the top one.
Oh, it was DEF CON then. Okay, DEF CON. Go back over to the right, to the blacklist. DEF CON's currently on the scumware blacklist. I just find that funny. If you're familiar with that particular blacklist, you probably know why, but it's just funny, right? It's scumware.
So, that's about all we've got. If anyone has questions, we'd love to talk. Let me go back here.
We have a microphone that's live up in the middle there if you want to ask questions.
Do it.
So, right now there's no integration with Splunk in this tool. We're using the Splunk Python API if we want to talk to Splunk and writing separate scripts. Does that answer that question?
It's basically a roadmap item is really what we're getting at. So right now, everything that you're seeing right now still requires a human element on the back end to take the data, analyze it, do something with it, right? So the goal is once we have this, you try to eliminate as much of the human element as you can so that your people are just focused on the facts, right? They're not going out and collecting all this information. Well, right now, one of the things they're still doing are they're crafting their own Splunk queries based on that. And so once you get to that point where that's automatically generated also, then it starts to become prettier. Like, have you used crits before? Have you used crits before? No. Okay, so in crits, when it does the data correlation and shows like, oh, these are related domains, it generates a Splunk query for you. You just click the button, right? So if we could have something like that eventually, that'd be fantastic.
Yes, sir. So the question is the cache clean enough to import into Splunk? Yeah. I mean, you could dump it out as JSON and put it in Splunk or any other SIM if you want to be able to query it. Actually, you could drop that right into Elasticsearch. That would work perfectly. But you could also keep it in Postgres and do queries as you like and integrate it through the API. There are any number of options. It's modular.
Go.
That's it.
So, sometimes you'll get a large group of files, already figured out how to get new files. Do you have a way to integrate these dumped in from this and here and automatically say, is it this role, is it our photo?
So right now we don't have all of the hash stuff implemented. That's on the roadmap. That's something I've been developing for our internal use, actually. So that'll make its way in here. And if anyone wants to contribute.
You just volunteered, buddy. Yeah, you did. Huh. Gotcha. Okay, the tool that I wrote, Bacon, it does take hashes, but butchering that basically and taking his expertise with the awesome way he does things the right way, apparently, whatever, and put that in there. Yeah, that'd be so roadmap item. Yeah.
There's one in the back.
So basically data aging out question.
Aging out, not really handled with any depth right now. It defaults to, if a query is over 30 days old, redo it. You can force it to update. But that's kind of an interesting question, something that's, on a blacklist tomorrow may not be there today. And that part's, up to the user.
Well, let me ask you, in your firewalls, whatever you're using, when you block a domain, what are the intervals for your block? Do you block forever? Do you block 1 month? Do you block 3 months, a year, 2 years? Okay, so can you actually provide a time frame for expiration, like custom, based on each block? What do you base that decision on? All right, yeah, got to be. So the idea is, like, say there's a consulate that gets hacked, quote unquote, and all of a sudden they're redirecting users to an exploit kit or something, right? But I mean, you're a big company and you need people to be able to hit that consulate's website. You block it for 3 months, but it's cleaned after 2 days. Like, whoops, right? So that, yeah.
And a reminder, we have a microphone up here if you want to talk.
So is Postgres, and for dev purposes you mentioned SQLite, are those primarily your data stores, or are you involving any graph databases as well, given the highly deep relations between some of the data?
So right now this is not tightly integrated with much of anything else. I'd say we've got...
Tell them the truth, dude.
Yeah.
We're going to do a talk. So we're like, database, go! That's the truth. Yeah, that's going to be fleshed out more, to be honest.
Any further questions?
What's that?
All right. Thank you very much, gentlemen.
Cool.
Please be sure, pack it in, pack it out. I have to pick up anything that you don't, so...